Fantastic to see so many people are already joining for today's session. So welcome everyone to these PTC talks, where we are honored by having Ove Coopers from our alliance partner Calypso today for a session on sustainability and energy management and how to approach a net zero target. But first, a very quick introduction by me. So my name is Torbjörn Peterson and I'm the alliance manager for PTC, leading these webinars where we also invite customers and partners for some inspiration on digital transformation to see what is possible and how to make things happen. And we are running all these webinars on Fridays, same time, 3 times a month, with different kind of topics around either manufacturing, services, or engineering. And all the recordings have to be found on the registration site. And the agenda for today is first a quick overview of PTC by me, and then Ove will run the show by introducing himself and touch base on a few challenges and how to address these, and then explain some of the business outcomes. And at the end, we are also having a Q&A session, so please keep your questions to the end, or you may also put them in the chat, and we will pick them up later on during the Q&A. So now over to the next slide, Ove. Thank you, sir. So PTC is a global software company with a headquarters in Boston, and we provide market-leading solutions on IoT, AR, PLM, SLM, and ALM, and CAD through the digital thread, to help companies to accelerate some of the digital transformations. And we are also having AI also integrated in some of the PTC solutions. So now over to you, Ove.
Thank you very much. Yeah, and welcome everyone. So topic for today is really talking about sustainability and energy management and how to approach a net zero target and how do we leverage PTC in this way. So when we look into sustainable, customers are really looking into the insights and how to converting the data into actionable insights for the sustainability and productivity, as well as understanding the impact on scaling the impact and the visibility across the whole value chain from a product lifecycle and the ecosystem around. And then obviously we're looking in what are potential innovations we can drive with our partners in scaling new climate tech production and securing that we have a net carbon footprint reduction happening there. So from there, when we look into that, looking to what we call the digital thread, from the discovery idea creation point of view to the production, to how do we sell product, we basically see that every step has an influence in the CO2, has an influence on the side that we have the greenhouse gas in there. So what I was talking about is when we look into the digital thread and all the different parts in there. So when we see in this, we're starting from a discovery perspective where we design already the products for a sustainable move there. We look into what can be done from a digital twin perspective to really design that eco-design point from an idea creation point. How do we design already for recycle and remanufacturing of that? And then being able of really utilizing the PLM side on driving an eco-design in this environment of the products we want to create, which allows us as well to simulate and modeling this in the best way. And then we're looking, how do we secure waste reduction in the start of the development of the product already? And how do we make sure that when we bring it in the manufacturing environment, that for the scope 1 and 2, all aspects are covered there. So what energy do I use? What is the raw material I've used? Can I substitute some raw material in that matter? And how do I drive that in the best way to really understand that I capture all the carbon footprint I have, all the energy usage, and optimizing as well the energy suppliers I potentially have from a renewable energy, from my energy sources I have, and also being able of seeing what energy sources I'm using I can reuse for within my environment by myself. And then obviously when we go into the selling environment, there is a question of how do I move the parts I've done, how do I bring them back in a circular economy as well in there. So let me go here and see now if it works again. I hope it does. Looks good in this way. So that we've really been able of looking, how do we design for sustainability? How do we create a digital twin for the eco-design? Using the PLM for defining the sustainability already and really doing that from a life cycle assessment already. So how can I optimize my supply of my material? What are alternatives materials? How do I design the product in the best way? How do I use algorithms and AI for that as well to understand potential improvements can be done in certain ways? And then looking as well in the manufacturing environment, as we said before, how do I optimize to closed loop control to reduce my energy? How do I do productivity, quality, and sustainability, keep them in a triangle and optimizing the usage of my energy in the best way? And then having the circular economy where I'm thinking about how do I dispose the material in the best way? How can I reuse, recycle, and waste the material in the best way? And any of this has obviously an influence. And specifically, when we look to the greenhouse gas emission and the traceability, and how do I reduce then specifically with a focus on the scope 1, 2, and 3. And therefore, we've really been starting from a point that we say, how can we drive the sustainability and decarbonization assessment? So as mentioned, the sustainability services and offering we do is really starting from supporting you on the product development. So what is the right design for the sustainability? How do we drive this, the life cycle assessment in there? How do we secure from a manufacturing perspective that we empower the energy management with AI, with forecasting, demand forecasting, reacting on high energy cost and suppliers by really choosing what is the best way of doing this. And I will show later on some live videos of the application there. How do we integrate renewable energy? How do we secure waste reduction? And then obviously coming up with the reporting for this to really make sure that on the scope 1 and 2 and 3, you have your reports being required from a regulation perspective also is there available. The distribution channel obviously is an important part as well, looking from an upstream and downstream emission. So what kind of supply do you use? Where's the material coming? Where's it going for? And also there, we have a high influence on the CO2, and that needs to be looked into that. And then seeing as well, how can we prevent maintenance? How do we have the smart connected products there that we really know how the circular economy is being used in the way that I've been able of tracing the waste, the reusability, and the disposals of the products. So looking into that in a detail, the sustainability and decarbonization assessment is something we go quickly in now. So when we look into that, starting with a simple point of doing an energy audit, and not saying that this is a simple activity, because it really covers a lot of things. How do you really examine the buildings, and how do you use your production facilities, and what are the energy suppliers you have, and how do we do emission improvements in this area? So this is all what we look into to understand what is really the actual energy situation you have. And based on that, then extending that with a digital and data assessment, where we understand what is your digital landscape, what data are actually available today to really enable us for enable you to empower the sustainability and energy practice which are there. So do we have the right metering in place? Do we have the production data in place to really do the contextualization, which is important to do? And out of that, we then been able of creating a value case assessment where we estimate and analyze the cost. And I'll show an example of that as well to really see what is the greenhouse gas impact of each individual use case we see across the sustainability portfolio we're going through. And based out of that, then being able of targeting what are the 2, 3, 4 highest use cases we should start with to really get the fastest value and benefits monetary, money-wise back to you. And based on that, having that roadmap over the next years being ready for focusing on. And we do that with the scope 1, 2, and 3 assessment. So really understanding how do we measure, account, and analyze the greenhouse gas emission across the whole supply chain. So We have also worked with the World Economic Forum to create what we call the net zero path for non-excuse for becoming net zero. So you see that framework has different stages, like how do I build a net zero corporate strategy? How do we set the capability for the carbon footprint? How do we accelerate energy efficiency in operation and transport and decarbonizing energy sources? How do we pursue material efficiency in the operation? How do we rethink product design and business models? How do we develop carbon capture solution and offset of mechanisms? And then into the systematic collaboration, how do we drive value chain decarbonization at upstream and downstream side? And how do we mobilize the ecosystem for net zero infrastructure? And then looking as well, how do we address that net zero data and digitalize it in a standardized way? And then obviously as a last point, we need to look, how do we implement and drive that net zero culture in your organization in the best way? And below you can see the link down here, which refers to the PDF. So I highly recommend to download that, or you just go on the QR code and scan that, and you will have that PDF available there as well. So I go quickly in some of the parts where we go a little bit more in detail what it says. So if we build a net zero corporate strategy, you obviously need to understand what is the current carbon footprint you have. How do I create the roadmap with a clear governance on there? And how do I build the business cases? Because without a business case, no one would start anything there, just for the matter of being greener is one part, but always it's better to look what is the money we can achieve for it. So therefore, we need to align the objectives from a sustainability perspective, understanding what the stakeholder implication is, and how do we do knowledge transfer, assessing the energy management, and then what is the IoT infrastructure you have, because that's important for us to really get the measurements of the data being available and do the contextualization there with the products you're producing at the time where you use the energy and how to drive that in the best manner. And that gives us the baseline of the greenhouse gas footprint and using the international standards for measuring that and then doing the carbon measurement plan. And with that, we build then the roadmap for the value cases towards the net zero target. We also have the energy management and generation strategy and government's model in place then. And then we set the capabilities for the carbon footprint monitoring, which means I need to align with the report requirements and enable the digital capability for the reporting and monitoring, which I will show in a couple of minutes, where we then go and start with initial scope on the 1 and 2. So that means for my own production and for the products I'm producing. And then looking for the escalation to the scope 3, which implies then the supply chain on the upstream and downstream. And therefore, the first initial step would then be deploying that platform, getting the data connected, and then doing the contextualization and have that automatic real-time reporting being available. And I will show the out-of-the-box application we have built there on the thingworx platform, which allows you to do that in a quick manner. Moving quickly forward, where you can think about for yourself, how mature are you in this matter already? And you can do a judgment for yourself during the presentation here, where you think, am I in the area where I have disparate systems, limited infrastructure, and siloed data, which are leading to the manual practice you do today? Or are you already more connected and being able of having an energy monitoring established with some dashboards in there, but the contextualization might not be there with the production data or might be already there? And then when you want to move towards the intelligence, is really how do we use the central dashboards for all the facilities to achieve a consistent across the sites and streamlining that from a management perspective, and have the energy forecasting available and utilizing machine learning algorithms and capabilities to really not only do the prediction and moving into prescriptive, but also being able of understanding how do I optimize my energy usage in the right way based on the production I'm having and the utilization of my assets, where I then move into world-class, where I drive this more autonomous and really leveraging AI and machine learning in an autonomous way to drive that in the most effective manner so that you can see peak load balances, being able of switching off, switching on energies based on the reaction, or even resequencing orders based on the cost of the energy. To look further, there's where you obviously need to look in what is the data science and IoT core capabilities you have. So we can add there, and we have done a lot of projects in the product lifecycle intelligence, which is basically utilizing machine learning and AI on top of PLM data being available to understand what can I optimize in my product design. Then the advanced process control with predictive maintenance, reducing downtimes, because that has an influence on sustainability directly as well. Using machine visions, for example, as well for reducing quality issues, which also has an influence in the sustainability, and the digital twin to really replicate complex process and simulate and optimize that. Together with smart connected products, where we monitor, update, and controlling the device from a remote perspective, and having the performance improvements capability, and then focusing on the energy management and sustainability. And additionally, you can see this really goes from a design, from a customer attached to the trust environment. How do I drive my design for a long life product? Because as longer the product life is, as better it is. And how do I drive for product life extension? So how do I design for an easier repair, replacement of parts, designing for upgradability, designing for standardization? So you see there's a lot of potential when we look into the overall life cycle assessment we can drive here. And I don't want to go too much into detail and further because of the matter of time. I just show here an example of a client we did where we identified 15 projects, and where these 15 projects were identifying roughly around 95% of emission reduction in the scope 1 and 2. So you can see that really we looked detailed in there, and we identified opportunities from over 1.9 million on annual energy savings. How do we drive this? It's basically out of that assessment, we've been able of giving you a picture of these different elements and use cases being identified. And you can see, based on the category we have here, that it really has to do not just with production optimization, but also how do I optimize my facilities? How do I drive converters in a better way? How do I do chiller optimization, boiler optimization, putting a new solar panel on the roof, and then measuring that, understanding what is really the optimum payback I can get, what is the size of the CO2 reduction, what is the cost of the implementing for each of these use cases, and how technical difficult it is. And based on that, you see a multidimensional picture coming out of that, which we have represented on the right side, showing the potential savings, and then make it a formal decision with the client on saying, these are the areas we want to focusing on. These are the 3-4 use cases we start with to create really the roadmap in this matter. Okay, so when we look into the first step, as we said, starting to manage the energy management in a better way, that is what we have built a solution on the thingworx IoT platform, and really drive the sustainability and energy management in a better way, and creating that IT/OT conversion-based platform for this matter in the best way. And we've been able of connecting to whatever is there in the field. Might that be the weather condition, might that be the energy meters, the gas compressor meters, and the production environment, obviously, to really provide you with the energy management dashboards, the sustainability, greenhouse gas, and doing the optimization and analytics. So what we see here is an overview of our solution we have built on thingworx, which basically gives you the water, air, gas, electricity, and steam data extraction, and providing that as a report, continuing with the alerts and notification that you see where boundaries have been reached or risk is being identified, and then have directly a carbon or greenhouse gas footprint tracking and seeing the compliance from a reporting perspective, and then being able of doing the energy optimization by the data correlation, by the advanced analytics, the models for the energy usage and the power demand forecasting we're having. And then that gives the foundation, obviously, directly as well for learning, for adding machine learning control optimizations and opportunities. And you can see doing an MVP, a minimum viable product, means for us, we want to install that in a quick manner. And that could be depending on how much effort or preparation is done by yourself already, that could lay in the average between 6 to 10 weeks. Therefore, we say in an 8-week, we can normally deliver that. And the MVP for us means that we could do that, for example, on a line or a specific area and prove the value in a very short time. But doing that in the manner that you see the benefits being received, as well as that the architectural wise, everything is ready for scale out. So the scale out of that solution then might just take another 2 to 3 weeks within your facilities. And we enable you as well to do that by yourself. So you're not becoming dependent by ourselves. That is a solution where we implement that and train you and enable you to drive this by yourself. And in that stage, instead of going further on the PowerPoint, I might just do and give you a short video on this, where you then been able of seeing that in a better way. So let me go into the video here and let me know if you can see it. I hope you can see the application here. Where you can, perfect, thank you. Where you can see here on the left side, the model of your plant, where we go from a site-specific point into an area, and then you then have the capability of seeing by that site or by an area or by a line the hourly view, the daily view, the weekly view, the monthly view, the yearly view, or even seeing here that you've been able of selecting a specific time area. And you see by that the energy cost, the production, how many units are you producing, the cost per unit by that, by the contextualization, seeing the energy cost per wages by area, and you see as well the cost versus the production in there. And I'm just moving a little bit further so you see some of the information. You can see on the top right side as well, on the bar graph, that you can download that data as well, being able of putting that into another graph. When you go on each individual point, you immediately see the value of that each individual selection as well. You've been able of putting that into a trend slide or going into the details of the wages and seeing here what are the consumption on the electricity, on the water, gas, and air, and the intensity we can see there. Just moving forward as well, as I mentioned before, you can change the timing here, look into from a daily perspective, from an hourly perspective, or selecting just the foreseen time frame in there. So further there, you then can drill into more details of that, where you have the detailed view on the total wages per sub-level, where you see, again, the energy cost, the production versus the target, and you see the overall consumption, the intensity, and all that information in there, which shows you, for example, what is my demand, what is my consumption versus my production, and how the intensity and the total cost of energy is, and what is the average demand I'm having, as well as the peak demand in there. Just moving forward, and that you obviously can look from all the different energy sources you have, where the data is being available, and the information can be contextualized in this matter. So further to that, we then have the capability of showing the consumption demand versus the production, showing the cost versus the production of the individual areas, and then moving ahead with even go into the individual assets you might have there and having the detail of the assets with the location, with the demand, if they are connected, and if there's an error in there, as well as the consumption of in this sample here for power monitoring in that overall solutions. You then been able of seeing my flow, my energy flow, my selected meter and the consumption. And now we come in here where we've been able of seeing basically the energy flow in the matter that I see where was the energy sources and where was it used to. So what we see here is basically if I go, you can see and gliding with the mouse over it, what energy source has been used in what product and how much it was, so that you immediately been able of seeing where do I have, and these are simulated data, therefore the bar graph is in a similar size. If you have real-time data, the size of the bar is even different and shows you immediately visible what intensity you have from what energy was used for which product. On the right side, you then see the heat mapping, and the heat mapping basically gives you the capability, and let me go over here, gives you the capability of showing at what time in the day did I have the highest usage of energy, and therefore then defining the activities, how do I eliminate these heat points and peak points on my energy, which sometimes in some countries might bring you to the point that this is costing additional money if you come over the agreed pricing situation, the terms, right? So you can then select the time, the days, and really being able of putting actions behind there where you measure the base, and then you immediately out of that, after you continuous improvement activities, you see the results of that as well moving forward. So here you've been able then, again, seeing the historic consumption, you can select the reports, and there's several of them, as you can see, which we can just go into and do a check on the consumption versus production, the consumption versus intensity, and all these is very quickly to see, and you can select the energy type, you can see the cost versus the target and the cost per unit versus the target there as well. And then, as mentioned, we can change in any of the slides immediately, how do I want to represent that for better analyze and understanding better what is possible in this matter. So with this, you then been able of comparing as well the different sites with the different energy types and seeing how are these doing against the different sites, site A, site B, area A, area B, product A to product B, and so on. So it allows you a lot of comparison, understanding fast what is possible, what do you achieve, and how do I optimize my energy consumption, or how do I optimize my greenhouse gas and CO2 footprint. So it's really up to your imagination what you want to drive there, and that could be done as well if I'm comparing on a trend level, doing this and comparing the sites again, the areas by machine, by energy type, and creating the trends in that matter for whatever is needed from your side there. Okay, and you can see here that I'm able of bringing the trends in from different areas, different energy types, which I'm able to comparing with each other, and really driving this in a good manner. Always following using the ThingworX model, which brings the data in, contextualizes there, and then enables us to really utilizing our out-of-the-box application in that matter in the best way. And I'm just moving forward, and you can see that the consumption, the intensity, the compressor efficiency, all of that is then being compared with each other and gives you the best insight to really enable you and understanding how do I drive the optimization and how do I manage my energy in the best way. Same with the forecasting, with the emission base we have here, the intensity. So all of that capabilities in there. You have your emission factors, which you can bring in. Either they are available already, or you type them in manually, because to calculate the greenhouse gas emission, we obviously need to have the emission factors, which might be in your ERP system because of the contract you have with your energy suppliers, or you might need to do that in a new certificate, or you might to enter them manually as well. So, and then alerting, you can build your own alerts as well easily and configure them. So where you define the rules, the targets in there, and therefore having these rules are for critical, and that could then point out to an email notification, an SMS or text message in there. And you can see how easy that is to configure that in this manner and in this way. Okay, and with that, I think we're coming to the end where we obviously discuss and look as well to the tariffs you have for each individual energy sources you have. So again, they could be connected or you type them manually in, and seeing as well what is the peak hours we have, what is the consumption rate you have with agreed with your energy suppliers. And therefore, all of that is possible to bring in. It's a full thought through application for analyzing, optimizing, and moving you to initiatives, which we see here as a part where I've been able of adding any kind of initiatives, putting the baseline in, and therefore seeing what was the achievement I have done by that specific initiative we have assigned people to in this matter. And you see, it's really a surrounded application which allows you to do all of what we explained and discussed before. And therefore, that's basically where we come to that end and saying we have really the full capability of a fast implementation of our custom build application, being agnostic, depending on what you have in your infrastructure, on what meters you have in there, following the ISO 50001 principles here, having the production contextualization and having the standardization for how do I manage my energy on the enterprise level, how do I drive my sustainability focus and goals down, and optimizing my footprint and focusing on the scope 1 and 2, reducing the cost of the in-house development and realizing quickly within 8 weeks, immediately getting that, and then having that platform, the IoT platform here, really as a foundation for adding as well other functionality, like we have built as well solutions on SPC, statistic process control, which will see the process variances and therefore having a higher quality, and higher quality directly has an impact again on our sustainability footprint, and allows us to add more and more functionality on the machine learning algorithm side. So with that, I just go back and go quickly on the architecture as well, which gives you a picture on how that could be made in this way. And you see here the ThingworX platform, which we are connecting to, and this is just an example where we connect to either controllers or direct to the meters, to the PLCs, bringing them in through the Kepware, having then the contextualization to utilities, weather information, as well as to your ERP, MES production information, historical information, and then doing the contextualization here on the ThingworX platform. Our application is fully built on the ThingworX platform, leveraging all the capabilities PTC has, but it allows us as well to add then machine learning algorithms, training, advanced analytics into that, and connecting with and showing the results in there. So results we have achieved in the different areas there is when we look into connected energy and smart facilities, energy facilities and demand side management, load management, supply chain optimization, utilizing renewable integration, emission reduction, plant cogeneration integration as well, sustainability innovations on the product itself, or as well looking into EV fleets, how to utilize them. And here's just 5 examples of implementations we have done, and the usage might it be in steel, might it be in tire. We also have done lately in the food industry implementations on that. So it really doesn't matter what industry it is. You can see there's always a good potential of savings. And wherever there's a high energy intensive area, that is obviously something where we directly been able of supporting you and helping you in there. Starting from the assessment, looking then into the energy management and optimization area. And with that, thank you very much for your attention and looking forward to your questions.
Thanks a lot, Ove, for this fantastic overview and a lot of, good demos here. So, we will spend a few, more minutes, to have some Q&As here. So, we had one question in the chat, and that was from Kamlesh, and he had a question regarding the graphical interface. Is that, created in ThingWorx?
Yeah, most of it has been created on ThingWorx. We have created 2 or 3 graphical elements which we added on the ThingWorx platform, but it's all built on the ThingWorx in the way that you can extend the graphical view, obviously, by yourself as well. And the graphical elements which you might not have known from the ThingWorx side are third-party components which we embedded on the ThingWorx as well.
Thank you. We have one question from Pratap also.
Yes. Am I audible?
Yes.
Yeah, sure. Right.
Okay. So my first question is, how do you provide an ROI-based proposal for audits and surveys before initializing the value proposition? If the customer has already conducted a preliminary audit and survey by themselves, what payback offering involves selecting this plant as one of the pilot first and then delivering KPIs to other similar plant of this customer? Another one added to that, the defining is the approach to defining the KPIs and SLS top down, bottom up, or combination of both. And with the energy management and decarbonizations, what's the takeaway for the water footprint? After you give the answer of this, just addition to one lingering part of that will ask after the answers are available for me.
Okay, maybe you can put the questions in the chat so I make sure that I remember all the points. But starting on the first point.
So I put up the questions actually, and also I typed the remaining ones.
Okay, great. So starting with the first question, and John, maybe you might help me on the questions to remind me. But starting on the first one, so if a client has done an assessment already, we would take that as an input for us and understanding how far he is and what are the areas based on the methodology we have built up, what is missing, and really looking into that. So the assessment exists out of understanding what has been done in this area already, having then discussions with individual stakeholders, understanding what the IoT landscape is, the application landscape is, and also what is the actual situation on the metering they have, and specifically on the cost. And based on that, we would immediately understand, so what is the CO2 footprint, the greenhouse gas footprint they have, and the activities they are using there, and what is the energy cost. And based on that, we can identify on a first glance already if it is worthwhile continuing. I think that was your first question on there. And then if we have done that and we come to the conclusion, yes, it's worthwhile continuing, then we do the detailed analysis of that and understanding based on the use case I showed, on the outcome there, what is the potential return on invest for each individual use case, and what implication will have from a energy saving point of view, what it will have on the CO2 footprint point of view, and what is the cost of that implementation, and the effort timing wise, and the technical difficulties. And based on that, we rank them in the multi-dimension picture I showed as an example, where then you can define in common with the client what is the common roadmap we want to go for. Did this answer the question?
Yes. And also I asked another question. So approach of defining KPIs, SLS, top down, bottom up, or combinations, and in context of that's combination. So in the context of energy management decarbonizations, any takeaway for the water footprint? And then I have one last question.
Well, the water footprint obviously is depending on the products you're producing or the amount of water you use, might it be for cooling. So this is different from industry to industry. Do you use it for cleaning? Do you need it for cooling, etc.? What is the determination and the what is the end result of the water, which means, is it being wastewater? Is it, how do you call it?
Generally, for the process industry, we come for the cleaning and washing, actually.
Okay, correct.
Yeah.
So therefore, it's then as well where we also, because we're not looking just from an energy, but also from a process perspective, is there
Yes.
ways we can optimize and reduce the water for cleaning and washing in the way that we use reusable water and not just only clean water and then have wastewater out there. So we also look from the overall process perspective into that as well.
Yeah. And I started my question with that the process you start with the energy audit, but before while we offer the proposal value propositions, so in that itself the audit and survey discussion should implement ROI based, or do we claim that once the audit done we again come back and identify the KPIs and then come back with the ROI?
Well, there's different steps in between. As I said, we can start with an overall glance and do a high-level discussion and seeing, is it worthwhile to start the assessment overall, based on your industry and based on the usage and based on potential savings we know from the industry knowledge and from the process knowledge.
So for the industry benchmark comes into the play, correct?
Correct.
My
And
last
then,
question. Yeah.
yep.
In digital twin scenarios, we often encounter challenges with the test and training data, model accuracy, and realizing the benefits with the ROI for boilers, heaters, and evaporators. Once the ROI is achieved with the trained twin model, what is the approach of handing over the twin to the actual operational?
Well, just our experience on the digital twin is quite extensive. And when people are talking about digital twin, we always need to differentiate what is the digital twin you are talking about, because digital twin is moving from the digital thread point of view. So we have multiple digital twins connected to the digital twin, to the digital thread, to allow that seamless flow of data. When we look from taking the example on the boiler and chiller as an example. So also there we have industry and process knowledge people which knows exactly how these instruments are running. We've been able of simulating and doing an emulation by really connecting the live behavior of the equipment to the digital twin, and therefore then adding applications like our energy monitoring and energy management application, and using, for example, there as well algorithms which are then being able to connect to that, and having that digital twin as a complete emulation of the system, which can be handed over to the client. But we first been able of proving that by ourselves that this works in this matter, and therefore moving ahead with the client in this matter.
Exactly. There, here comes the challenge. So what we face actually, so customers' expectation is the subject matter expertise also should be aligned with the twin provider. So there
Correct.
the process expertise, subject matter expertise also need to be there, and one step ahead that he would like to that I am paying the value. You should give me the right KPI from the twin model what you are approaching. So identify the twin on behalf of me also. So particularly in the applications like boilers, chillers, evaporators, where we need to, though the process is complex, but we need to apply the process in such a way that the customer's pain area will be addressed in the better way, actually.
Yeah. And we do have these experts within our teams. I mean, as we are part of Rockwell Automation, we can leverage the knowledge within our organization, where we have process experts doing nothing else day in, day out by optimizing the boilers, the chillers, the evaporators in this case. And we have a strong partner network as well within where we can leverage that to really bring this in.
Thank you. It was a
You're
great
more than
insight.
welcome. Thank you.
All right, I'm sorry to say, but I mean, time is running out, and I think, I mean, it's been a fantastic, I mean, overview from you over, and a lot of, I mean, really good, I mean, questions, I mean, from the audience here. So, I mean, thanks you for joining, and thanks to you, Ove, I mean, for this, I mean, great opportunity to have you here as, I mean, a speaker. So with that, I hope to see you back also to the next, I mean, PTC talks on the 16th of February for a session about connected service, optimizing your service strategy with IoT by PTC. So stay tuned for that and have a fantastic weekend, everyone. To see you back then. All right.
Thank you very much for
Thank
the
you.
opportunity here. And if you have any question, please feel free to contact me at any time.
Super duper over. Looking forward to that. Thank you, everyone.
Nice weekend.
Bye-bye.
Bye.